Hello, I'm Karen Pamela Vázquez Thierry, and I'm going to show the results of my study, the biomechanical applicative study of the upper extremity arthroplasty in patients with total amputations and its effects due to the phantom limb syndrome. According to the US statistics, there are around 1.7 million people with one or several of their limbs that are amputee. Referring just in Mexico, the INEGI has registered around 785 million people with some degree of amputations, and the traumatic amputees are especially the accidental ones, are the most common permanent disability. These numbers are increasing year and year. The syndrome of the phantom limb, called the PLP, has been a term presented regularly in a limb amputation. It implies not just the physical changes, also psychological and social and labor repercussions. It is difficult to treat, and it's a serious worldwide health problem. The general objective of the study is to develop a myoelectric prosthetic device that collects information to evaluate the muscular status of the patients with total upper limb amputations, as well as studying the PLP. The methodology that was being designed consists in four main stages. The first one is instrumentations, which is the design and all the assembly of the myoelectrical signal measurement device. Then it's the calibration and the signal filtration, that there are parameters and condition adjustments for correct precision and accuracy of the values. Then the numerical analysis, which is the experimental development in the study group, and we are taking samples of both arms. And finally, the assessment results, which is the evaluation of the muscle status per patient and generation of different statistics and conclusions. What is intended to obtain? We want to measure a comparative of the myoelectrical signals of both arms, the healthy one and the amputated, with a recopilation of 3 microvolts impulses per recorded second. In this graph that you can see, it's an example of the data collected that has been graphed of a patient. The development of the device is a composition of several stages according to this scheme, where first the nerve muscle fibers with the major activity must be identified, to then put the sensors and electrodes on those specific points, and through the coding of the Arduino system, the collection and processing of data is extracted and become to a graphic. So here in the illustration we can see the electrodes are being placed on the healthy arm and on the amputee, and finally the results will give data enough to compare and to analyze. The codification stage is very important in this develop. You can see here in the graphic on the right side that it was the test sequence number B that was the best calibration acquired. A series of calibrations were required to achieve the correct data collection. Here we can see a correct level of precision, where the instrument reveals the same result in different measurements, and a correct level of accuracy, where the results are close to no value of the test. The results were applied in the study group during the campaign of free prosthetics donations of the LN4 hand project in coordination of the Club Rotario Valle de Mexico. There were 20 volunteers that collaborated with the study in ages between 4 and 68 years old. The numerical analysis per patient were like this sample that we can see here. It has several data, personal data, and also data that was revealed with the study, such as the muscle disturbance level, and also the minimum and maximums that were reflected on this graphic will tell us different kind of information that we can evaluate, and not just to determine if the patient have the syndrome, also to determine if their disturbance of the muscles and the precision was correct, enough to use a prosthesis. Statistically, 12 to 20 patients have the symptoms caused by the PLP, and it's an increase of the positive cases with traumatic amputation. The cases in which it was detected the syndrome, there was a frequency of symptoms such as tingling, sensation of heat on cold, burning, sensation of movement, tingling, numbness, and burning. In conclusion, it was demonstrated that the electromyographical signals are different between the healthy and the amputated arm. Furthermore, it was identified that the syndrome is almost null in congenital amputations with a notorious presence in traumatic amputations. The test was able to analyze when the patient was receiving the correct rehabilitation of their stump according to the disturbance of the muscles and the precision in relation with time and force that were applied during the performance of the exercises of the study. Finally, the study gave the opportunity to analyze the patients with the presence of PLP and the ones who needed to reinforce the rehabilitation to the corresponding area that can help them to evolve their muscle state in order to be able to use any type of prosthetics.